Okay, our next topic is molarity. This is another form of concentration of the four that we're looking at for this section of chapter 12. At this point, we've defined the two ways already as percent solute and mole fraction. And for molarity, you can see that the word molar is in there, so this is going to deal with moles of solute. So it's going to involve a fraction which mole is going to be used in some fashion. In molarity, which is commonly used in aqueous solutions, the number of moles of solute compared to the number of liters of solution. So the best way to represent that is molarity, which we use a capital M for, and the label is going to be moles per liter, but we're going to keep it as a capital M. This is going to equal to moles of solute over liters of solution. And like I said, when you work this out, you're going to get an answer in moles per liter, but we don't use that moniker. You say it when you use the capital M, as we have here. So like if you get an answer of 0.250 capital M, you would read that as 0.250 moles per liter. Okay? So let's use this example as to how we can use this formula. This is what is the molarity of a solution is 40 grams of sodium chloride is dissolved in 750 milliliters of solution. Okay, so we have 40 grams of sodium chloride and we have 750 milliliters of solution. So what we want to do here is use the formula M equals moles of solute over liters of solution. So we have two conversions we have to do here. Change the grams to moles and the milliliters to liters. So we have to use our periodic chart. We find sodium. The mass for that is 23.0, and the mass for sodium chloride is 35.5. All right, so our numerator then is going to be equal to 40.0 grams times fraction line 1 mole over, and then if we add this together, we get 58.5 grams. And that's going to go right down here, 58.5 grams. Over, and then we change the 750 milliliters solution into liters. So 750 milliliters times 1 liter over 1,000 milliliters. Now, we don't have to put it in this form here. You can simply find the number of moles and put that right on top here. And you can take the number of liters from this and just put it right there instead of putting it all in parentheses. And then you divide the two out. And when we do that, we get 0.912 moles per liter. And like I said, make sure that you say moles per liter and not big OM or capital M or whatever. And also I want to point out to you that because I typed all this out, I had to use a capital L for liter. That's not normally how it's done, but you will see some textbooks do that for the same reason I'm doing it, and that's because the L and the 1 look an awful lot alike. So to avoid that confusion, we went ahead and used the capital L for this. Let's take another scenario here. Let's suppose that we have, we're going to make a potassium bromate solution. And we want the concentration to be 0.650 moles per liter, and we have 300 milliliters of that solution, and we need to know how many grams that's going to be. Okay, so 300 milliliters, 0.650 solution is what we were given here. So let's take a look at that. So 300 milliliters of solution. This is so much fun getting old. I just love it. Yeah, 0.650 molar. Why not? Okay. 0.650 molar. Solution. So the question is, how many grams? So this is the information we have, and this is what we're trying to solve for. Now again, we go to the formula, M equals moles of solutes over liters of solution, and plug in what we know. We know that we have 0.650 moles per liter, and we have 300 milliliters of solution. We can change that to liters by putting 1 liter over 1,000 milliliters, and this will give us 0.300 liters, and we can plug that in right here. Now this becomes just a basic algebra problem. In fact, if you want to make it really look like an algebra problem, you can put an X right there. Don't have to, but if you do, that's fine. So you take your equation here. Now there's one of two ways we can solve this. You can put a 1 under this and cross multiply, or recognize that your variable's in the numerator, which is really good. So all we have to do is get rid of the denominator. Had the variable in the denominator, then you would have to put the 1 under and cross multiply. Because when variable goes to the denominator and get rid of the number, that doesn't give you x, it gives you 1 over x. And that tends to be problematic for some people. So to avoid confusion, if you like to do the same thing over and over again, just go ahead and put a 1 and cross multiply. And that's what I'm going to do. It's not the way I normally do it, but I want people to get into a mathematical pattern so they don't run into mistakes like when that x is in the denominator. So we cross multiply, and we get 1 times x equals 0.650 moles per liter. And now I am going to write moles over liters because I'm going to have some cancellation things going on here. Times 0.300 liters. And the liters, like I said here, are going to cancel out, so that is going to leave me moles. And 1 times x is x, so x is going to equal to 0.195 moles. But we have an issue with this answer. What is that issue? Well, we didn't want to know how many moles were, we want to know how many grams of potassium bromate this is going to be. So, we have to convert this to grams. So we go back to the periodic table and find that potassium is 39.1 grams, bromine is 79.9 grams, plus 3 oxygens, so that's 3 times 16.0 grams. I should have put the grams at the end, right outside here. It's probably easier, because we can see that's what we'll be left with for an answer. And then we put 1 mole in the denominator. Moles cancel out, multiply this garbage out, and that's going to give us our answer in grams, which I've done on the script here. And we get 32.6 grams. So these are pretty easy problems, and I like molarities, but probably my favorite of the 4 because of the uses we have for it. It's used all the time in chemistry. Molarity and molality are probably the 2 most used ones, which is the next thing we're going to talk about. Practice problems then. I want you to do 49 and 50 again on page 548. The ones that we did the mole fraction for, but for those I want you to find the molarity under these conditions here, where you have in number 49, 100 milliliters solution, and the solute is isopropyl alcohol. And number 50, the total of solution is 4.55 liters, and the solute is ethylene glycol. All right? Have fun.